Here is a question. Read it carefully and think about the answer. Let us solve it step by step. Let us begin solving this step by step. Identify the final product and work backwards. The final product after Wolff-Kishner-type conditions, NH2NH2O delta, is ethylbenzene, C8H10, a benzene ring with an ethyl group. The Wolff-Kishner reduction converts a carbonyl, C is equal to O, to a CH2. So intermediate B, C8H8O, must be a carbonyl compound that gives ethylbenzene upon Wolff-Kishner reduction. Moving on to the next step. Identify intermediate B, ethylbenzene is pH, CH2CH3. Wolff-Kishner of a ketone R-CoR gives R, CH2R. So B must be pH, CH3, I, acetophenone, C8H8O. This matches the molecular formula C8H8O. Moving on to the next step. Ozonolysis of A, C16H16, gives B, C8H8O. Ozonolysis cleaves AC is equal to C double bond. Since A is C16H16 and ozonolysis gives one product B of formula C8H8O, two equivalents, since 2x C8H8O accounts for all carbons and oxygens added, each fragment from ozonolysis is acetophenone. This means both sides of the double bond in A give pH, CH3 upon ozonolysis. And for the final step, determine the structure of A. If ozonolysis of A, an alkene, gives two molecules of acetophenone, pH, CH3, then A must be the alkene pH, CH3, C is equal to C, CH3, pH, I, 1, 2 diphenyl 1, 2 dimethylethylene, still be an analog with two methyl groups. This has the molecular formula. Each carbon of the double bond carries one pH and one CH3 group. Formula C6H5C, CH3, is equal to C, CH3, C6H5 is equal to C16H16. Confirmed. Match to answer options. Option B shows pH, CH3, C is equal to C, CH3, pH as the E isomer trans configuration to separate structures shown side by side indicating stereoisomers or the same connectivity drawn differently. Option C shows pH, CH3, C is equal to C, pH, CH3, which is the same connectivity as B, just the Z isomer or the same compound drawn from the other perspective. Both B and C represent the same constitutional structure pH, CH3, C is equal to C, CH3, pH but as different geometric isomers, E and Z. Both would give acetophenone upon ozonolysis, and both have formula C16H16. Option A is pH to C is equal to C, CH3, 2,1,1 diphenyl 2-methylpropene, which upon ozonolysis would give pH to C is equal to O, benzophenone, C13H10O, and CH3 to C is equal to O, acetone, not acetophenone. So, A is incorrect. Conclusion. Both geometric isomers, B and C of 1,2-diphenyl 1,2-dimethylethylene satisfy all conditions, so the answer is D, both B and C. Therefore, the correct answer is D. Therefore, the correct answer is option D.